This question is taken from the ENGAA 2020 Section 2 paper, and it is question 11. So we read, 3 identical resistors can be combined in 4 different arrangements. One arrangement has resistance 18 ohms, another arrangement has resistance 8 ohms. What are the resistances of the other 2 arrangements? So it might be a good idea to picture what all these possible arrangements could be so that we can deduce which one is which. So we have the 3 in parallel, all the 3 resistors in parallel, all the way down to 3 resistors in series, and then we have these middle 2 where we have some parallel and series mixing. So the one with the most pathways will be the lowest resistance one, and then the one at the bottom with all of them in series will be the highest resistance. So if we work these out, we know this will be R over 3 on the top and then 3R here. So R over 3 uses the principle that when you do 1 over R, when you add those n times, you'll get n over R. Then you flip it, should get R divided by the number of branches. And then how can we get the other 2? Well, the second one from the top will have 2 over R. We'll have 1 over R plus 1 over 2R. So this will be 3 over 2R. So then flip this, we get 2R over 3. The third one will have R plus R over 2, because it's R divided by number of branches. So this is 3R over 2. So we've got expressions for these branches in terms of R, where R is the resistance of each individual resistor. But we still wouldn't know which one corresponds to which. So it might be a good idea to look at the answers. So we have a range from 2 ohms and 4 ohms, and then 81 ohms and 162 ohms on the bottom. So it's a good idea to look at these answers because we have so many options for these that it's hard to know where to even begin. So it's best to narrow down our options as much as possible by looking at what the possible options could even be. And then this still doesn't help in knowing which one is which one is 8 and which one is 18. Well, we know 8 can't be the highest resistance one, so it can only be the other 3. So we could see what happens if 8 ohms, the total resistance, is any of these arrangements. So if the first one is 8 ohms, then we have 8, and then this is 16 because this is double that arrangement, so 2R over 3 compared to R over 3. Then going to 3R, this is 9 times R over 3. So this is 9 times 8, which is 72. And then divide this by 2 to get the third one, we get 36 ohms. So this has to be wrong, because there's 8 but no 18. So this can't be the right arrangement. Okay, what about if 8 ohms was the second one? Then 8 ohms would be here. This one would be 4 ohms, as it's half the second resistance. Then again, like we did before, if we times that by 9 to get to 3R, we'd get the 36, so 4 times 9 is 36. And then if we halve it again to get the penultimate arrangement here, we get 18. So we have the ones we desire, 8 and 18. So the answer must be D. So 4 and 36 are the other resistances of the arrangement. So one of the best tricks to know in this, when we were trying to get all the resistances between them, is to notice what factors or multiples each one is of the other. So to get from 2R over 3 to 3R over 2 directly would have been quite messy, so it would have been easier to go from R over 3 to the 3R by multiplying by 9 and then going back the other way. So sometimes you have to take one step backward in order to go another 2 forward. So the answer is 4 ohms and 36 ohms for the other resistances.